Hello, everyone, and welcome to another episode of Bad Dependencies. My name is Mackenzie Jackson. I'm here with research extraordinaire Charlie Eriksen. Charlie, how are you doing today?
Hey, I'm good. Just a slow day. It's rainy, it's gray, and it's like, thank God we have some delicious malware news to keep ourselves warm.
Keep us toasty and warm. Juicy malware news. I don't think we need to beat around the bush. We actually found some interesting things, and this is kind of new. We haven't really talked about this type of attack, but on Friday we discovered something pretty fun, pretty funky. You want to tell us kind of what happened Friday for us?
Yeah, the thing we haven't really made a big deal out of is that we recently, well, actually a while ago, we started also scanning OpenVSX, which is the open registry for Visual Studio Code extensions, which is different from the official Visual Studio Code marketplace, but it's not fully a mirror, but mostly similar. And we started to see a bunch of extensions on there being compromised. And the thing that was really interesting about it was that it was with a technique we had seen before already back in March, and we published about in June. And we had been wondering, because it was a really cool technique using these like private use parts of like Unicode, like these non-printable characters. And there was this whole, like, we first saw it didn't seem to do anything other than print like a hello world. Then they updated it like a couple of weeks later and it started doing more. There was a blockchain component to it and a Google Calendar invite and all kinds of things. But
I remember
there was
this
nothing
malware.
at the end.
I remember this malware very well. I've done some presentations with it. I described this as some of the most beautiful malware that I've ever seen in terms of like, it was very sophisticated. So a lot to kind of unpack there. But when you're talking, let's start with OpenVSX. So this is for VS Code extensions. So the IDE, you're plugging in it. It's also for things like Cursor, if I'm not mistaken, and other kind of reuses of VS Code. What's the primary use case for OpenVSX as opposed to the official VS Code marketplace? Let's start there so that we can kind of understand the landscape.
Yeah, so I'm not sure about the exact nuances, right? But obviously the Visual Studio Code marketplace is meant for Visual Studio Code. We now have all of these forks of Visual Studio Code, like Cursor, Windsurf, and all of these products, right? That become really popular thanks to AI. And I believe that they use OpenVSX instead of the Visual Studio Code marketplace, right? Because it's the Microsoft proprietary. So it's a way, in an open way, for people to share extensions for these forks of Visual Studio Code. So they can get their themes, their different extensions for supporting different languages, all kinds of fun things, to improve the developer experience.
So, okay, so now that we know kind of what was compromised, a whole bunch of these was compromised. I want to start with kind of what did the malware do? Like that was that. So they compromised these extensions and they injected malware into it. What did that malware do?
Yeah, so the malware was basically it had a lot of components to it. There's some good write-ups out there, about what it's actually doing. It was basically a grab bag of all of the different things like a remote access Trojan would do, right? It tries to put in some backdoors, remote access, stealing things, you name it. It's kind of similar, but just much more sophisticated version of what we saw from the rat that was in like Rand user agent and got fetch from some months ago. Just way more complicated, right? It does so many things. These people put in a lot of work into that. That's for sure.
Yeah. So let's get into kind of some of the interesting things, because as you said, we've seen this before, and it's not just that we've seen this technique before. We can be very confident that this is the same threat actors because the code is essentially the same. is that when you look at the malware, what it appears to do is decode a base 64 string. But when you look at the string, it's only one single character. So what's happening when they're trying to decode a single character? What's going on behind the scenes there?
Yeah, so what they have is that there's two things that come together. One is that you have the actual JavaScript code where there is this call to a decode function. And if you just look at it in many editors, it will just show you like a single character. Because if your editor is not configured to show non-printable characters, it will not show these Unicode characters that actually are present that doesn't have a symbol on machines, right? On whether it's Linux or Mac or Windows. So it's just not going to show them to you. So it's actually like a big blob that it's decoding, and there is this native module that it's calling a node native module. And that is just a native module that takes this string. Well, I guess it's kind of a binary, or actually binary literal in a sense. And it is doing a little bit of decoding to return a actual reasonable ASCII piece of code to be run. So they have obfuscated the decoding into this native node module to make it more difficult to figure out what is going on. You actually have to execute it or do a lot of reverse engineering to figure out what it's doing. And then what it gets from that, it just runs, right? It's just JavaScript code.
Yeah. It's super interesting. And, I was having some discussions about this with people too, and it's kind of like, this is very sneaky in the sense that humans can't see it. Like, well, without the right tool, you can't see it. But because we've known about this technique for quite some time now, it's kind of like a bit of a red flag in terms of like detection systems. So it's like in some parts it's very stealthy, and in other parts it's kind of like a giant flashing red light that like, hey, invisible characters, probably dodgy.
Yep. Right. So that's the beautiful thing as a defender, right? From my perspective, they burned this technique when they put out their first test packages, right? Yeah. Because the first thing we did was we went and wrote a rule saying, if you have a bunch of non-printable characters, well, we're going to review that all right. That's how we found it so quickly. We actually found the first one on first day. I remember posting in Slack like, hey, guys, you remember the Unicode thing from months ago? Well, here's what they're going to do, right?
Yeah.
Now they're starting to use that technique.
So it's very, very interesting going on from there. Now, why do you think, when we first discovered this, it in NPM, as you said, back in March. We posted about it. I think it was May, June. We then like published about it. Well, that was NPM. Why the transition to VS Code? Like, do you think is this just kind of new attack vectors? Is VS Code? Do you feel like VS Code is like particularly vulnerable? Like, what's that transition like?
Yeah, I think, it makes sense in a way, right? They would start to go for this way because there has been a fair bit of talk lately about how that is kind of one of the new frontiers. Because what people are really going for very often, right? The attackers, right? They're trying to get onto the development machine, steal things. See this with Singularity, Shai-Hulud. A lot of these attacks, they are going for all the secrets and access to the development machine because that is incredibly valuable. And it's also worth a callback to the interview we had with Raphael about his research on Visual Studio Code extensions, how the sort of moderation of that was maybe not so great. You could actually get malware through on there quite easily. So I think it's really a coming together of a lot of the trends that we're seeing, right? Whether it is going for these smaller ecosystems that are also really high impact and haven't had the same scrutiny put onto them in terms of the sort of security controls, which we'll get into later as well, to protect that ecosystem. And then picking out a lot of the best, like the top hits of different techniques, right? Whether it's the worm component and obviously the technique they had around Unicode and things like that, bringing that together into one big package as an opportunistic thing. That's kind of how I see it. It's a lot of it's innovation together with a lot of stuff we've seen already, and it's just like bringing that together creates something much bigger than itself.
Yeah. And you can see that the transition of attackers are like pushing all the vectors at the moment. They're just trying to find all the weak spots. They found a massive weak spot in NPM. They've been exploiting that for a long time, with marginal success. Some big progress there, and now they're starting to push on other areas of the supply chain. Let's move on just for a minute here and actually start talking about kind of those weaknesses, because we've been very critical of NPM, right, within reason, right? We're not. Yeah. NPM is a great tool, great people, great things, but there's been a lot of attacks. Something's needed to change with security. We've pushed hard against that. Other people we've had on the show, like Josh Junon, has pushed hard against that. NPM appears to have listened. Now, I'm not going to claim they've been listening to me or to you, but they've been listening.
I'm sure they did.
Yeah, I don't know if NPM listens to this. If they do, shout out, guys. We do love you. I know you've got a hard job. But they have listened and they've updated their security policies. What have they updated? Let's start there. Like, what has NPM actually implemented?
Yeah, so we knew some of the stuff was going to be coming. The most recent kind of changes came into effect starting here about a week and a bit ago on the 13th of October, which is changes around access tokens. Mm-hmm. So the first thing is that you have these thing called granular tokens, which are these tokens you can create where you can define what access it has. And they have changed the policies there so that the default expiration for these tokens are 7 days instead of 30, just to reduce that window where a token could be vulnerable. And they have set a maximum expiration of 90 days instead of unlimited. And that's really important because what we saw, like with Shai Hulud and Singularity, is that they would have these token, they would steal them, publish them, and then for Shai Hulud, right, they had been sitting on them for a while and then decided to use them way past when they actually stole them. So by really limiting the actual lifetime of them, you minimize the possibility that if something leaks, then that could be used in a malicious way.
It also kind of makes the secondary market harder because, just to explain to some people too, is what often happens is you'll have a group of threat actors that will steal tokens, discover tokens, and then they'll sell them to a secondary attack group. So you may specialize in kind of phishing campaigns or something like that, and you've managed to get some NPM tokens, and then you then sell them to a different access group that's can convert that into some kind of financial gain or objective gain, whether it be a state-sponsored actor trying to get into things or converting it into cryptocurrency or whatever. So this kind of limits that ability to be able to find and sell tokens because the timeline of which you have to do it is extremely limited.
Yeah. Yeah, so that's the first thing. The other thing is you have these classical tokens, which are basically tokens that have access to everything and has no expiry date. And those are really scary. So what NPM has done is that they've gone, okay, we've removed already the ability to create these types of tokens. And over the next 5 weeks, so the next kind of 4 weeks from the day of recording today, they are revoking all of the existing tokens. Easy. It might break stuff, right? Things in CI/CD pipelines, things like that. But frankly, I think this is just setting a good example. I know there's been a lot of discussion before this about oh my God, the world is crashing. This is terrible. How could you ever do this? The world will. No, come on.
I feel like you're teasing me there, Charlie.
Well, if you've said this, then yes, I will teach you. But like some people had concerns that this will break automation.
Well, it will, but we can fix it. Like it is going to break automation. It is going to disrupt things, but we can fix it. And I think the security benefit is worth it.
Yeah. The thing is, people are so locked into the old way of doing things that they don't realize there are other ways of doing this that work perfectly well. That does not have this downside, right? When I deploy stuff into AWS, right, I manually go in and I have a little script that I invoke. And I put in my two-factor, and it gives me a token for 8 hours on my machine for that specific session that I can use, right? And yeah, it means I have to do something once a day when I'm working. But in reality, right, that is the name of the game, because we can't have these long-lived tokens, right? We have to have some sort of mechanism for saying, hey, is this actually a person that is intending to do this? And they have to take some sort of out-of-band action in order to actually give that sign that, yes, this was what the user intended to do.
Got it. You got it. And, I mean, moving away from tokens, what else has kind of been implemented here from the NPM side? Are there kind of other things that they've also changed? Yeah,
so... they have disabled the ability for people to use time-based one-time passwords. And you'll only be able to do web authentication and passkeys for two-factor authentication, because that solves the problem that Josh ran into of one-time passwords or TOTP ones being phishable.
Yes, got it. And so, like... And if everyone's not familiar, which I don't know why you wouldn't be if you're in this podcast, but things like the Google Authenticator app, that's a time-based thing, and it means that if I'm very quick and I can copy that code and then log in with it myself, then there's a window where that is phishable. Whereas these other methods kind of doesn't matter. It's based on asymptomatic encryption. Is that right?
Asymmetric.
Asymmetric. Oh, yeah, sorry. There we go. Okay, Josh, I want to ask you a personal question. As someone that's been advocating for these change, you got your wish. Some of the changes has been implemented. Does it go far enough?
I think it goes quite far. Yeah, absolutely. Are there still things that on a more systemic level will need to change? Yeah, and I think... NPM realizes, Microsoft, GitHub, whatever, realizes this. One of the things that they are saying is that this is just a small piece of the overall problem. And I agree with them. One of the things that they are pushing hard is this thing called trusted publishing. And that is the system where, together with, for instance, like GitHub Actions or GitLab CI/CD, you are able to set it up such that when you build a package through one of these CI/CD systems, it will also sign the packets for attestation and then upload it through a dedicated channel such that you have this full like end-to-end sort of attestation flow. So you don't have the ability even to upload a packet that was just like uploaded from a random desktop somewhere with a token. And that solves the problem also of the fact that a packet on NPM, if it's not attested, has no inherent relationship to a open source repository like on GitHub or GitLab. Like there's no connection whatsoever inherently. And if you're going to, where does the trust really lie? Because in GitHub, for instance, right, you have so many ways of saying, okay, well, you can only push code into the main branch if one person has reviewed it and accepted it, and only these people can push into main. And in terms of trust, right, that is the type of mechanisms that actually allows you to build trust through a set of sort of policies about how a project is run. You don't just have the ability to push into the thing and, well, then you don't know what happened, what led to that build being pushed.
Yeah.
Yeah.
And it means that you can layer security in one place instead of having to layer it in multiple places, which is kind of what we are now. Now we've increased security on an NPN, but if you make the connection in only between GitHub and NPM, then I guess in a way you could just really push all your security to GitHub, all your reviews, all those process of commands, and then that has the same impact on NPM if you can only push through those accounts. So. Yeah. I guess that does make sense, but then again, that also raises other questions. Then is, of now you have to use GitHub. Now I'm not a user of SourceForge or anything else from the 90s or early 2000s, but I mean there is an argument to be said that we shouldn't all be forced to use these different products. And I guess from the Microsoft point of view, forcing that you have to use GitHub. Even if you add GitLab and that in there, is kind of a little, being that they're both owned by Microsoft, could be seen as a little bit challenging.
Yeah, so GitLab is GitLab, right? They're separate. What they're also saying that they're going to support Azure pipelines, Circle CI, and other pipelines, or platforms, rather.
Okay,
right. So it's about the trusted publishing, right? The trusted publishers, right? That they're expanding support for. To sort of solve that problem.
Yeah. Well, I think it's. I mean, overall, I'm a fan, and I think it's really cool that the community made a big fuss, and I think it's great that NPM listened. Interesting enough, you can't please everyone, right? When NPM announced this, they did it through their GitHub channels. We were sending messages to each other about, certain comments from people that were on there, very upset about these changes. So you're not going to please everyone, but I do think that these changes are definitely in the interest of security. And I think what we saw recently was that the scale of attacks got to a point where we can no longer ignore this. We have to do something.
Exactly.
Yeah.
Thank God.
Thank goodness. Well, Charlie, it's been a pleasure sitting down and chatting with you. Some cool, juicy malware, some great security updates. One final question before we go off the air. Are we going to see less malware pushed to NPM as a result of these changes?
No, but it will be less impact.
Okay. I think that's a good answer. All right, Charlie, all the best. Thanks everyone for listening, and make sure you subscribe to the channel. And if you can't subscribe because you're listening on something like Spotify or that, then please give us a 5-star rating. Really appreciate it. We try our best to bring you up-to-date information. So if you could do us that small favor, that'd be great. And we will see you on the next episode.
See ya.